Now let us start exploring the structure of an atom. So we know that atom is the smallest particle that has the properties of the element itself. So it is like the basic building block of any material. So gold is made up of gold atoms, and iron is made up of iron atoms, and every other element is made up of small atoms, right? So yeah, so let us now in the coming videos, let us start exploring the structure of an atom. And so first of all, whenever you are asked to imagine any atom, what is the basic shape you imagine? Well, it is most probably a simple sphere, right? You imagine an atom as a ball, right? And that is what early scientists did. So there was a scientist called J.J. Thomson, and this person imagined the atom as a ball, as a sphere. And so that is the basic idea. So he imagined that every atom is essentially a sphere. Now he had the task of telling us what is inside this sphere. What is this sphere made up of? Right? That is a very natural question that comes up. What is this sphere made up of? Is it just one solid sphere, or does it have further components inside it? So it was known that it was through experiments, it was known that if you take any sheet, so obviously a sheet is made up of atoms, and so through experiments they found that under certain circumstances, I'm not going to get into too much detail what those circumstances are and all that, but they did some experiments and they found that some types of matter, they emit certain types of particles that are charged. So they were small, so these things emitted small particles that were charged, and they were actually negatively charged. Now there were many experiments that they did to find that this was negatively charged. I'm not going to get into all that, but they found that this thing did emit small negative charges. So one thing was for sure, that this atom certainly did contain these negatively charged particles. So obviously these small negatively charged particles, much smaller than the atom. So the atom was composed of these small negatively charged particles. But they also knew that the atom on a whole was neutral, which means it had no net charge. So in the previous video we've seen that in the previous video we've seen that if you have a box in which you have, let's say, a positive charge and a negative charge, equal amounts of positive and negative charge, the net charge inside that box is 0. So then they knew that this atom, because we know that matter around is not charged, it has a net 0 charge. So they knew that the atoms that they were looking at, that the atoms they were studying, the atoms were neutral, which means that the atom had no net charge. So let's say this particular atom had these charges inside it. Let me change the marker. So let's say I have 3 such small particles, negatively charged particles inside it. Now if I have only these 3 negatively charged particles inside it, then this should be charged, right? This should have the charge of these 3 particles, but this has no net charge or 0 net charge. So that means there has to be an equal amount of positive charge. Now where should I place the positive charge? Now Thomson just guessed it out, and he said that maybe this atom is like the rest of the atom is positively charged, this space between it, and these negative charges are embedded into it. These negatively charged particles are embedded into it. So he gave the example of a watermelon. So if you have ever seen a watermelon, how do watermelons look? So if you cut open a watermelon is generally spherical. If you cut open a watermelon, the watermelon has this red part, right, which you eat, hopefully. This has the red part that we eat, and so he compared this red part of the watermelon to the positively charged part of an atom, and he said that just like a watermelon has this red part, and in that red part we have some seeds in between, embedded just like this. So he compared these small seeds to the negatively charged particles that were present inside the atom, and this solved the problem. So now I can extract the seed out of, just like I can extract seed out of the watermelon, we can extract these small negative charged particles from this atom, which justifies the result that negatively charged particles were obtained from atoms. But the whole atom as a whole is neutral, because we have these negatively charged particles and it's positively charged outer area, just like the watermelon's red part, and he called this positively charged soup. So it might be like a soup, and inside the soup we have these negatively charged particles. And one last note, these negatively charged particles were then called electrons. electrons, electrons. So these negatively charged particles called electrons were embedded here, and surrounding them was this positively charged soup kind of thing that was equal in magnitude. So the value of charge of this positive charge was equal to the negative charge, so that the net charge on this whole atom is 0. And that is how J.J. Thomson came up with the first model of an atom. So this looks pretty good, right? I hope, yeah. So this looks pretty good to me. This looks like a decent model of an atom, and this, so people believed in that those days, yeah, that this might be. So this is how actually an atom looks like. So yeah, that's it for this video. And this was called the J.J. Thomson model of an atom, or called the plum pudding model of an atom. Why plum pudding? Because in those days they had this plum pudding. Not in those days. Even now we have this. We have a pudding. He called it plum pudding. So rather, a pudding is just like a muffin. And so he imagined the pudding as this, the major part of the pudding as this positively charged soup, and in that muffin we had these raisins or dry fruits that were like the negatively charged particles. So yeah, that's the basic. So you can either compare this to the watermelon, or you can compare this to the plum pudding or their muffin here, and it doesn't really make a difference. But the basic idea is that this is the J.J. Thomson model, or the plum pudding model, and this is the first model of an atom. That's it for this video.